Enzyme catalysis definition I am telling you. All enzymes are nitrogenous organic complex molecules, nitrogenous organic compounds. These are obtained from the living plants and tissues, living plants and animals. The nitrogenous enzymes are nitrogenous organic compounds. Enzymes are nitrogenous organic compounds. Obtained from living plants and animals. That is the definition. Okay, enzymes are nitrogenous organic compounds obtained from the living plants and animals. That is the definition. You can observe here, this is the definition of enzyme catalysis. Enzymes acts as a biocatalyst. These are obtained from the proteins. Some more points I am telling you, see here. This is the definition of enzyme catalysis. After that, examples are there, some are examples. For example, sucrose hydrolysis, it is converted to glucose and fructose. In presence of sucrose, we are calling invert sugar. That's why here he is producing invertase enzyme. That is one example. Second step, glucose is converted to ethyl alcohol and releases CO2 gas. Here enzyme is gymase enzyme. Sucrose, second step is glucose is converted to alcohol and CO2. And third step is one more you can take, that is starch. In presence of diastase enzyme. In presence of diastase enzyme, it is converted to maltose. That is one more point. Then maltose, it contains number of alpha D glucoses are combined to form 2 alpha D glucoses are combined to form maltose. Suppose maltose and hydrolysis, these are all hydrolysis reactions. Maltose and in presence of maltase, the maltose is converted to in presence of maltase enzyme, it forms glucose. Next one, we are taking carbohydrates. Carbohydrates are converted to glucose in presence of amylase enzyme. Next one, suppose proteins are there. In presence of pepsin, those are converted to amino acids. Actually, what happens means here in our stomach producing two, one is pepsin, proteins are digested by the pepsin and trypsin. Pepsin is one of the enzyme. It reacts with proteins and it is converted to peptides. That peptides reacts with trypsin enzyme. Those are finally converted to, otherwise you can take trypsin also. Proteins in presence of pepsin converted to peptides. That peptides reaction with trypsin in presence of, those are converted to, finally it forms amino acids. Next one, after pepsin, trypsin is over. Suppose any oils are there, in presence of lipase enzyme it reacts and it forms fatty acids. It is stored in our body. Suppose curd how it forms, for example milk, buttermilk we are adding, in that one fermentation we are doing. Curdling of milk, in the presence of curdling of milk means we are adding little bit of buttermilk. Buttermilk contains lactobacilli, one of the bacteria is there. It is converted to, milk is converted to curd in presence of lactobacilli, that one. Next one, urea is there. Urea in presence of urease enzyme, it is converted to ammonia and CO2. Okay. This is also one more examples for the enzyme catalysis. Last one I am telling you, see here. After enzyme catalysis, characteristics of enzyme catalysis. Characteristics of enzyme catalysis. Characteristics of enzyme catalysis. First point, enzymes are highly specific in nature. Highly specific in nature. First point. Second point, enzymes are highly efficient. Next one, enzymes are most active at optimum temperature. Next one, enzymes are most active at optimum pH. And next one, enzymes are most active at activators and coenzymes. Next one, catalysts, in presence of promoters also there, and poisons also there. Okay, these points I am going to discuss. First one is enzymes, characteristics of enzyme catalysis. Highly specific in nature. Previously we discussed about selectivity. One catalyst we are using, one of the product only forms. Suppose here lipase enzyme only is there, it only reacts with lipids but not proteins, carbohydrates. That's why enzymes are highly specific in nature. For example, we are eating rice. Rice contains carbohydrates. How it will digest means in presence of amylase enzyme is there. It can react with carbohydrates only, but not proteins. That's why enzymes are highly specific in nature. Next one is enzymes are highly efficient. Suppose one molecule of the enzyme, it can react with more number of products it may forms. It can react with number of molecules. That's why we are calling enzymes are highly efficient. That one. Next, enzymes are most active at the certain temperature. That temperature is called optimum temperature. For example, nearby 298 to 310 Kelvin. 298 to 310 Kelvin. Next one, enzymes are most active at optimum pH. Nearly optimum pH range is 4 to 5 pH range. For example, you are doing curdling of a milk in presence of buttermilk. Buttermilk, when you are adding for the milk, there certain temperature is there. Room temperature only it will react. You will keep in deep freeze, it can't react. Because of that, bacteria is inactive at low temperature. Certain temperature is required, that is optimum temperature. Suppose milk is converted to lactic acid is there. Acid means that pH, that is weak acid. Then pH is nearby 4 to 5 pH. Okay, now the temperature is certain temperature. Where the reaction, the fermentation takes place at the which temperature? Room temperature only. Nearly 298 to 310 Kelvin. Okay, the enzymes are most active at optimum pH. That is called, that optimum pH is 4 to 5 pH. Next one, activators and coenzymes. For example, some activators are there: Na plus, Mn plus 2, cobalt plus 2, copper plus 2. These are the activators. For example, some enzymes are activated by Na plus, Mn plus 2, cobalt plus 2, copper plus 2. What is coenzymes? Coenzymes means, okay, enzymes having two parts are there. Protein part, non-protein part. Prosthetic group, protein part we are calling prosthetic group, and non-protein part, non-prosthetic group we are calling. Okay, here enzymes. The activity of the enzymes was increased by the coenzymes. The substance which increases the activity. Generally, catalyst we are calling promoters. The activity of the catalyst increased by the promoters. The activity of the catalyst is increased by the promoters. Here, enzymes activity increases. Enzyme also acts as a catalyst, biocatalyst. That's why the enzyme activity was increased by the some substances. Those are called coenzymes. For example, vitamins like that. Vitamins acts as a coenzymes. Next one, promoters. Promoters means enzyme activity was increased by the coenzyme. Like that, catalyst is there. That is promoters we are calling. Some substances are there which destroy the activity of the catalyst. Those are called poisons or catalytic poisons we are called. Later we will discuss now. Now these are the characteristics of the enzyme, characteristics of enzyme catalysis. After that 2 points I will discuss. I will stop this session. Next class we will discuss about. Okay, 2 points I am discussing about that. First one is promoter. Another one is catalytic poisoning. Catalytic poisoning or catalytic poison. What is promoter? Actually, Haber's process. Manufacturing of ammonia is called Haber's process. There, Haber's process means N2 plus 3H2 gives 2NH3. Here iron is a catalyst, molybdenum acts as a promoter. Actual iron in solid form, that is inactive. That's activity is increasing purpose. I am adding small amount of substance, that is promoter. Molybdenum acts as a promoter. Previously, iron is in inactive form. In Haber's process manufacturing of ammonia, N2 plus, these two are gases. Nitrogen is a gas, hydrogen is a gas. The formation of ammonia here. There iron acts as a catalyst. Its activity was increased by the molybdenum acts as a promoter. After that, promoter is over. Catalytic poisoning. Same I am taking here. N2 plus 3H2 gives both sides, gives 2NH3. Here, iron is a catalyst now. After completion of the reaction, ammonia more product is obtained. I remove that ammonia. After that, iron I don't want. Okay, now. I want to destroy the activity of the catalyst. In Haber's process, iron acts as a catalyst. Manufacturing of ammonia, iron acts as a catalyst. Its activity was destroyed by one more substance, that is called catalytic poisoning or catalytic poison we are calling. In Haber's process, we are using carbon monoxide also. It acts as a catalytic poison. Or H2S also, we can use as a hydrogen sulfide, that also catalytic poisoning. Okay, what is catalytic poisoning means? Definition what you will write. First one is, in Haber's process, iron acts as a catalyst. After completion of the reaction, iron don't want means its activity was destroyed by the carbon monoxide or H2S we are using. These two are in Haber's process. What are the catalytic poisons? Catalytic poisons are carbon monoxide and hydrogen sulfides. Okay. Today I am stopping here. Next, the remaining topics next session we will discuss. Thanks. Bye.